Hello and welcome to this video on XGBoost. Here we'll use XGBoost hands-on using scikit-learn in Visual Studio Code. We will work with the same hard dataset as we used in the random forest video. Here we'll use XGBoost and we'll try also Bayesian Optimization. There's a little bit new things going on here. Instead of scikit-learn, we'll use the XGBoost package. This will be quite interesting. Let's move on to the code directly. Here I am in Visual Studio Code and let's start with setting up our environment. If you're in Mac M1, M2, M3, M4, etc., you need to install something called libcom. You need to do brew install libcom. For me, it's already done. It will work. Otherwise, it won't work for you. Then we will need to install a few packages because now we're not using just scikit-learn anymore. Instead, we'll use XGBoost package, uvvnv, and then source.ven bin activate. Then we'll do uvpip install xgboost. Pandas, I need scikit-learn to do train test split. I need matplotlib. I need scikit-optimize because I will use the Bayesian Optimization to show you how that works. Then I need ipykernel to work with Jupyter Notebook. Okay, that was quick. Now I have my hard dataset. Let's start with creating xgboost.ipnb. Okay. xgboost. Then I will remove this one and change this to Python. Okay, import pandas as PD. Then we'll do df equals pd.read.csv. I will read this heart dataset. Let's say heart.csv. Index call equals 0. This is quite similar to what we've done before in the random forest videos. So df head. Okay. To see the dataset now. Okay, you can see this is the dataset, and then we'll do df dummies. This is also exactly like the video. pd.getDummies, df drop first equals true, and then x comma y equals to df dummies dot drop hd yes. Axis equals 1 and then comma, this is our target variable. And then I'll just copy this from the lecture note for train test split, but we need to import the train test split from scikit-learn.model selection, import train test split, and then I'll run this one. Okay, so this means that we have imported, we divide the dataset, we have a train test split, and now it's time for our XGBoost. We'll see how that will work. XGBoost. And for XGBoost algorithm, we need to do something called a pipeline. I'll show you what that is right now. Pipe equals to pipeline. From sklearn.pipeline, import pipeline. As from grid search video before, pipeline, you can put in several steps there. And here we'll put in XGBoost as one step. Pipe equals to pipeline of steps equals to a list of tuples. And our classifier, since XGBoost and based models don't need to scale the data, we don't put in a scalar. So we put XGB classifier. Here I'll have random states equals 42. This is my pipe. Cool as that. We have XGB classifier and here are different parameters that are by default. That looks like this. A lot of none. As you've seen, not so many are set. But now we will need to do some hyperparameter tuning. To do hyperparameter tuning, let's see, I'll remove that one. We will need some from skop. This is the scikit optimizer that we installed before. Import. I'll do Bayesian search CV. This is a Bayesian search algorithm to find different hyperparameters. So this is a more randomized approach compared to grid search, which was more the exhaustive searching. You can use grid search if you want, but I choose to use Bayesian optimization here. skop.space import real, comma, integer, and then we'll do a search space. These are the parameters that we'll search. This is a dictionary. We'll start with the name is the classifier. Then we'll have max det. Max det integer 2,8. The classifier max det, it means that it's the tree det. The higher, the more depth of the tree, and that means that we get more complex trees, which means that it's easier to find more complex structures. However, this will also lead to easier overfitting. That is a trade-off here for max det. Then we have classifier, let's see, learning rate. This is the learning rate, so how fast it learns. And when it comes to trees, it's about how much each tree contributes to the ensemble. As in XGBoost and in random forest, we have several trees. In XGBoost, we are basically creating trees that will improve upon the last tree, attack the place where it has been weakest, and to minimize the error. Then the learning rate is like how much does each tree contribute to the fitting. It means that lower values, it becomes more robust because it learns, so each tree contributes less, but then we need more trees, we need more depth. That's the idea. Classifier learning rate, we start with real. With a real value between 0.001, so it's very slow, and 2.1, so 0.1. Then we have a prior, we give it the log-uniform. This is just what it should be as a prior, and then it will search for this in this space. Okay, then we have classifier CLF. Let's see, subsample, and subsample, what does this mean? It's a fraction of samples to use for the fitting. It means basically row sampling. You have your tabular data, and then you cut out the rows, you pick out a piece in your rows, and then you use this for the fitting. This is to reduce overfitting as well. So we have real, let's see, real 0.5, 1. And then we'll move on to classify a call sample by tree. What does this mean? This means it's a fraction of features, so of columns to use for each tree. You remember we have several trees, and then we don't use all the columns in each tree. Instead, it should be a fraction of it. So real 0.5 to 1. These are just the quite good baseline values that you can use when you're tuning the hyperparameters, and then you let the Bayesian search do its work for you. Okay, then let's move on. We have classifier call sample by level. By level means that there is a fraction of feature used for each level of the tree. For each level of the tree, we use a certain amount of features. We don't use all of them at once. It's also real 0.5, 1. Okay, then let's move on to classifier call sample by node. Here is that then you take a fraction of feature per split. Each node, it's a split. So here you don't consider all the samples either, or all the features either. Instead, it's just a few features. It's similar here, real 0.5, 1. Now it's time for some regularization. The regularization we have is CLF __ reg alpha. Reg alpha is basically L1 regularization. Then we have ridge regularization. Then L2 is the lasso one. These are also to penalize the weights. Here is a real between 0, 10. Then let's see classifier reg lambda. We have real also 0, 10. Then we have, so these are L1, L2. And then we have classifier gamma. This is basically, it's a minimum loss reduction that is required to make a new split. Here we have real of 10. Okay, this is the search space that we'll use. Then what we do is that we take optimizer equals to Bayesian search CV, and then we put in our pipe. We put in our search space. We take CV is the cross validation. We can pick it as 5, for example. And iteration, let's see, 20. Yeah, the more you pick, the longer time it takes for it to train, but maybe more robust. Scoring equals common scoring to use. Usually when it comes to more unbalanced data sets, you use ROC, AUC. Actually, you could use accuracy here since this is quite balanced data set, but this is a common, more robust one to use. F1 is also used usually. So random state 42, then we have our optimizer. Okay. So optimizer, what is this? It's this, you can see it's a pipeline of this XGB classifier with these parameters. Right now it hasn't set these parameters because you need to fit it in order to set those. So .fit xtrain x, let's say y train. Remember that we don't scale the data because it's a tree-based model. Here we train it, and yes, it takes a little bit of time. I think maybe 20-30 seconds. Oh, okay, it's done. Yes, then you see there's a lot of parameters that it found. Here are the parameters. You can see this by level, by node, by tree, etc. That it found different parameters. The learning rate is different, except the different, let's see, max depth is 3, etc. Okay, it has found different parameters to use using the optimizer, the search space, Bayesian searching. Now we can do optimizer.best estimator. You can see here is the estimators. It's the same as before. Then let's do here to find the different scores. You can do optimizer.best. Let's see. Or actually, I don't need to show that. I will do ypred actually. Optimizer.predict x-test. Then we have our ypred is a lot of zeros and ones. We can also do optimizer.predict probability on x-test. Then you can see here's the probability score, and then you can do :5, and you can see that yes, it has predicted different classes, yes or no on AHD. Then finally we do some evaluation. Here is, let's see, training, and then we're here in prediction. After prediction, we're in evaluation. For evaluation, it's the standards from scikit-learn.metrics, import classification report, confusion matrix display, and then print classification report, y-test, y-pred, and here you go. These are the results that we get. We have CM equals to confusion matrix, y-test, y-pred, and then we do confusion matrix display on CM, then display labels equals to no comma yes, and dot plot like this. This is the confusion matrix that we have here. This is the final results. Yes, it might be somewhat weaker than random forest if I remember correctly, however quite close I think. We can also take a look into optimizer best estimator.steps. Here you can see here's the classifier, and here is the different steps that we have in our optimizer, and in the pipeline we see we had the classifier, and here are a lot of different values, and we'll use these to pick out, let's see, if I take out 0 is the first one, is the tuple, and then I pick out the 1, and here you can see the parameters. This is the XGBoost model. XGBoost model equals to this one, and we can actually use this for plotting the importance. We can actually do this from XGBoost, import, plot the importance. They have a convenience function for doing this because this is quite useful that you do. You don't need to do what we did before in random forest video. XGBoost model, we just plot it like this, and then we can do plt.grid false, but we need to import from import matplotlib.pyplot as plt. Okay, great. Here you can see that, okay, here age is most, age, col, and cholesterol, and CA are the most important features according to this model. These were a little bit different from the random forest model. I think the CA was most important in that model. In this video, we have gone through XGBoost. This is a quite cool model, and in XGBoost, there's a lot of hyperparameters to tune, and we tune them using Bayesian Optimization. This was quite a little bit different from using normal scikit-learn only, but we still use scikit-learn for creating the pipeline. We used it for model selection, train, test, split. Then finally, we did the prediction and evaluation using scikit-learn as normal. Then we used XGBoost to plot the feature importances. I hope that this was helpful for you. If you haven't seen my other videos in random forest and decision trees, take a look at them. Then I hope that you learned a lot. See you in the next video. Thank you. Bye.